Hello everyone, my name is Yuki Tako da Costa Rego. I am a PhD student at University of São Paulo, and I'm going to present this work entitled Biodigesters in Peripheral Communities, a circular answer to mitigate energy poverty. And this work was derived from my master thesis. Without further ado, let me start by introducing some key concepts. First of all, poverty is multidimensional. It goes beyond incomes and includes limitation in access to health, education, and adequate living standards. In my research, I focused on three indicators related to daily life: cooking fuel, sanitation, and electricity access. In Brazil, around 85 million people lack adequate sewage service, and about 22 million live in energy poverty. When we talk about energy poverty, we refer to the lack of access to modern energy services, mainly electricity and clean fuel for cooking. These inequalities are not equally distributed. Environmental racism and weak public policies tend to exacerbate these conditions, especially in marginalized or peripheral communities. Now, let's move on. In many peripheral areas, energy and sanitation inequalities are deeply connected. The lack of clean cooking fuels increases indoor air pollution and health risks. But at the same time, poor sanitation contaminates water sources and spreads diseases. Therefore, solutions that can integrate both issues, energy and sanitation, can bring multiple benefits. And that's where biodigesters come in, offering a circular and decentralized response to both challenges. So, the main goal of my research was to analyze how biodigester can work as a circular solution for energy access and sanitation in a marginalized community. The study took place between 2023 and 2024, using a qualitative approach, including document analysis, field visits, direct observation, and interviews. The case study was developed in partnership with an NGO called Biosaneamento, which implemented several biodigester models in a favela known as Favela do Robertão, located in São Bernardo do Campo, São Paulo. The project was funded by private companies such as Scania and IWACP, and also through community crowdfunding. It was driven by social impact and the promotion of biogas as a sustainable energy alternative. Here we can see the location of Favela do Robertão. On the first image on the left, we can see Brazil's map. And in the second, on the right, we can see the state of São Paulo and the city São Bernardo do Campo. The NGO Biosaneamento implemented 5 models of biodigester as a sanitation solution. Home biogas was the only one that produced enough biogas to be used. Here we can see the entrance of the favela, and on the right we can see a house, and on the bottom we can see basic sanitation is urgent, which is the phrase from the Biosaneamento NGO. The context of this community is that Robertão is a semi-rural favela with unpaved streets and mixed housing. Some are made of wood, some are made of masonry, and the socio-demographic profile of the interviewers was that the population is mostly composed of women, and 66% identify themselves as black or brown. Here we can see the biodigester model that worked best in this case, which is home biogas. This system includes a toilet designed by the company itself, which is connected to the biodigester to direct the wastewater. There's also an inlet where organic waste such as food scraps can be added, and this organic matter is then digested by microorganisms inside the reactor and converted into biogas, which is piped to a stove. And the liquid byproduct that comes out of the process can also be used and as a biofertilizer for tree or ornamental plants. On the right side here, you can see a photo of the system in real life and a stove that is used by the residents. The results were very promising. On average, households reduced their liquefied petroleum gas consumption by 52%, meaning real savings for low income families. It also replaced firewood, improved indoor air quality, and reducing exposure to smoke. This photo on the middle shows this firewood stove from one resident that I interviewed, and her consumption of this kind of cooking food were reduced by the use of the biogas. From a sanitation perspective, it enabled the transition from open defecation to safe toilets, which improved hygiene and reduces the presence of disease vectors. And residents reported better living conditions and started to view a waste as a resource rather than a problem. So the system created both environmental and social benefits. In this slide, we can see how much families used to spend on LPG before the implementation of the biodigesters and how much they spent afterwards. On the left, we have the household income of these residents. In the middle, their monthly LPG expenses, and here on the right, middle right, how this expense represents a percentage of their total income. We can see an impressive change here on the first one. For example, the share of income spent on cooking food dropped from around 15% to about 8% after the biodigesters were installed. It's important to highlight the sanitation improvements achieved through the project. Here we have the sanitation ladder from the WHO and UNICEF Joint Monitoring Program. All of the residents interviewed moved from open defecation to safely managed sanitation after the implementation of the biodigesters. This represents a significant improvement in hygiene, health, and overall living conditions for the community. Additionally, it's important to highlight that untreated sewage naturally decomposes into methane, a greenhouse gas with a warming potential 28 times higher than CO2. Therefore, by treating waste through biodigesters, we can indirectly reduce methane emissions, even if that wasn't the main object of the project. Also, when households stop using solid fuels like wood, charcoal, or kerosene, they help to reduce CO2 emissions and indoor air pollution, another positive impact for both health and climate. The project revealed that biodigester can serve as a decentralizing solution, simultaneously treating waste and generating energy. This integration creates opportunities for local capacity building and environmental education, especially when residents begin to see waste as a resource. However, significant challenge remained. The project lacked structure, monitoring, and post-installation support, and the use of imported equipment raised concerns about cost and technological dependence. Broader barriers, such as the absence of regulatory frameworks and long-term funding, also can limit the scalability of such initiatives. Finally, community adaptation requires behavioral changes, which can take time and dedicated social engagement efforts. In conclusion, the findings show that biodigesters can contribute to cleaner production and circular resource management in contexts where access to basic service is limited. By transforming organic waste into energy and fertilizer, they promote energy sovereignty, sanitation, and climate co-benefits, even if indirect. Yet, structural barriers persist. Technological dependency, insufficient technical support, and lack of public frameworks restrict long-term viability. Therefore, advancing these technologies require intersectoral policies that link energy and sanitation while recognizing the social dimensions of these territories, especially the central role of Black and brown women, who are often the main users and caretakers of this system. Here are my references, and thank you very much.